Good morning to all of you. Am I audible? So, I am Kannan. I am a retired professor from Anna University, Chennai, and working as a senior professor at the School of Computer Science and Engineering, IIT Bangalore. So, I am going to talk about number theory mainly and the classical cryptographic algorithm. How many of you studied cryptography already? So, I will be handling mathematical part only mostly. So, even if you have studied cryptography also, you can reference your mathematics and few algorithms from cryptography also will do. Why we want to go for information security? Whenever you enter into the college, currently security. Why they are putting security is, they don't want to allow any intruders. So, inside web also, many people are intruding. They are trying to steal our valuable information. For example, they are stealing our bank password. Then they can get our money. In this way, the hackers, intruders, they are trying to attack the information stored in the web. To avoid that, we have to prevent, we have to provide new mechanisms for prevention. Since whatever way we prevent, they will be finding a new method to enter into the information which we store. They may be copying, they may be destroying, they may be modifying, they may do any malicious activity. To avoid all these things, different techniques are available. I will be focusing on only one technique called cryptography. Why we need information security is, we have to maintain confidentiality. Whenever I set a question paper for my BTech or MTech students, I set the question, put in a cover, take print out, put in a cover, outside the cover I write confidential, then I hand over to the controller of examination. If controller of examination is not available also, if I am giving in the office, if I write confidential, nobody should open. It can be opened only by the controller of examination. Why it is confidential is, if confidentiality is not maintained, anybody can take one copy of the question paper. If the question paper is copied by many people, then there is no use of conducting an examination. That is why, first thing, whatever information you have to have confidentiality. In this era, whatever personal information or secret information with respect to bank or education, anything, if you don't keep confidentiality, then you will be the loser. Somebody will be writing the bank password in a notebook and keep. And somebody will be writing the computer password and write in front of the keyboard, keep it in front of the keyboard. Like that, if you are writing your password, secret information openly, you are going to be the loser. We have to keep securely. For that purpose, we have to maintain confidentiality. The people who are intercepting, they want to take a copy of that. You see the first diagram. In the first diagram, so the sender is sending the information. It is going, one copy is going to the receiver, another copy is received by intermediary. Intermediary, he is a malicious user. Let us say he wants to sell the question paper or something, whatever secret information we have, that he wants to take a copy. That is the first thing. Second type of fraud, what they can do is, they can modify. You are sending a birthday wish to somebody, or somebody is succeeding, getting first mark in the examination. You are congratulating them. You are sending a message on congratulations. But intermediate person, he is taking your message, he is modifying the message that, why did you get first mark? I curse you, you should not live forever, you should die in 2 days, like that. He will modify, and in your name, your friend will be receiving the message. So sender is sending a good message. The intermediate person, malicious user is changing it After that, it is going to the receiver. This problem is called integrity problem. Integrity means who can modify, who should not be allowed to modify. So we should not allow modification of the message by any intermediate person. The sender should send it and the receiver should receive in the same form in which we are sending. That is the second. Third, authentication or fabrication. Sometimes when I was in Anna University, one outsider came on the first day of the semester. I allowed every student to enter into the lab. One man was coming with a fake ID card. He was also looking like wearing an ID card. But since I was taking the class for the second time, I know the students. I saw how a stranger is coming. He was not coming into the computer system. He was watching the bags of every student. Then I told the class rep, this student is not from your house, your class, I understand. You ask him who is. Then he told, I am a new joined, I came in second year, I am to this class only, like that he told. Then we inquired, after some time we found that he is a thief. When we found that he is a thief, I handed out to the dean and he handed over to the police. In this way, we were able to find out the person who was doing a fabrication or fake authentication. Authentication means whenever you go to the ATM, you have to authenticate you. How will you authenticate you as the correct person at the ATM? You have to give the correct card. First thing, if your card is fake, the ATM machine will not allow you. After that, you have to give PIN. This is the second thing. Even these two things are broken by the malicious users, the hackers. Therefore, now, for larger amount, if you are taking more than 10,000 rupees, they are asking for one-time password, OTP. So, these three mechanisms are used for authentication. So, authentication is very important in every place. When you come to the class, in VIT, in Anna University, no student will give fake attendance. But in VIT, it is a common thing that every student will, somebody's option means somebody else will give the percentage. So, I used to be aware on the first day itself I will count the cat and count the number of people who are present. Second day onwards, I will try to remember the faces and within 1 or 2 weeks I will try to say the names. Okay. In Anna University, I was not trying, but automatically it was coming. But in VIT, I try my best to remember the names. If you remember the name, then only fake attendance will not come. That part is fake authentication. Finally, non-repudiation. Non-repudiation means somebody send a message, but that message is disliked by many people. For example, it is against somebody or against a group, against the country. Like that, somebody is sending a message. Then, who is the sender? They will trace out and ask. He will say that I did not send the message. In my name, somebody else has sent. Like that, he will try to deny the message. That is called non-repudiation. You should not allow a person who is sending message to escape from denying. So he will try to deny. We have to say that you have sent it. These are all the 4 security goals. To maintain this, we have to go for different methods. Now I come to the technical part of my discussion. Cryptography. You are giving a plain text, for example, hello. Now you are using a key. Let us say it is adding 1 to every letter. H will be transferred to I, E to F, like that. If you are changing key equal to 1, then it will make a encrypted message that is called ciphertext. Non-decryption means if you are adding 1, you have to subtract 1. Reverse process. Then plain text will be received by the receiver. The term cryptography was coined from 2 words, cryptos and crack words, hidden to write, secret writing. So it was made to conceal message from unauthorized persons. So it maintains secrecy, not only secrecy, it maintains privacy. You can write letters to your friends in encrypted form. It is maintaining privacy means only your friends will be able to decode the message. All the others will be looking like some junk letters is there. Since you have written some character, that character is changed to some other character, therefore it is not readable. People will think that it is some new language. Many languages will be having the same script. For example, like English, many other languages are also using the same script. But if you read, it will be looking like English, but it's not the same language. Similarly, in India also, Devanagari script, it is used in many languages. So, it is providing secrecy, not only secrecy, privacy. Then we can authenticate correctly. Next, it forms the basis to many security concerns. These are the terminologies. Plain text, it is a message which you want to send. Next, encryption, the process of converting the plain text to a ciphertext. Ciphertext is an encrypted message. Decryption is reverse of encryption. Key, with the key only we are doing the encryption. So plain text, ciphertext, cipher, key, encipher or encryption, T-cipher, cryptography, cryptanalysis. Cryptanalysis means just by checking it, you can understand what type of letters are coming. For example, you are writing a letter, maybe starting with the place and date. The date, if you are not encrypting, then they will understand that it is DATE. For D, you are using this. For A, you are using this. T, date, 34 letters with that. They can understand what is the key. Once you understand the key, anything can be decrypted. So that analysis is called cryptanalysis. And cryptology is the combination of cryptography and cryptanalysis. So some of the cryptographic algorithms are symmetric algorithm and asymmetric algorithm. In the symmetric algorithm, whatever key you are using for encryption, the same key you will be using for decryption. For example, Caesar cipher, I told you are adding, you are subtracting with the same key. That is symmetric key. But in the public key, you may be using something else. For example, x and y you are using. You are while encrypting g power x, then other person key will be doing power y, g power x power y. The difficult man key change we do like that only. For example, I know x, you know y. Both of us know g. I find g power x, you find g power y. I send you g power x, you will be raising the power to y, so g power xy. And you know y, I am giving g power x power y you are doing, g power xy. You are sending me g power y, I am having x, I am putting g power y whole power x, I am getting g power xy, but I am encrypting with g power x, you are encrypting with g power y. So we are using different keys, that is only public key. So the public key, the encryption key is different from the decryption key. The sender will be using a different key and the receiver will be using a different key. In symmetric key, both the sender and receiver both are using the same key. In the public key, the sender is using one key, sender's public key or private key, and the receiver will be, suppose I am using the public key, it will be known to everybody. So the receiver will be using a private key to encrypt. The classical cryptography, that is the simple cryptography, we have substitution and transposition. Substitution means you will be substituting A with B, B with C, C with D, that is a simple substitution. Transposition means 1 goes to 2, 2 goes to 5, like that. Suppose first letter will be going to 5th position, second letter will be going to first position, third will be going to 10th position. So you will be doing like this. If I write the permutation in this way, 1 goes to 5, 2 goes to 6, 3 goes to 1, 4 goes to 2, like that if I am having, let us say, if I write it like this, 1, 2, 3, 4, 5, 6, if I want to encrypt, 1 goes to 5, that means K will be coming to 5th place in that decryption. So it is coming to 5th place. 2 goes to 6, that means A comes here. 3 goes to 1, that means N will come here. Like this, if you are changing, that is only இது எப்படி தெரியுமா? அருண் இல்லையா? எப்படி சார்? சார் ப்ரெஸ் பண்ணிட்டே ரெஸ்பாண்ட் ரைட். சரி. So this is the Caesar cryptography formula. Encryption of message E of M with a key K equal to C. Encrypted message will be called C, ciphertext, equal to M plus K mod 26. Decryption will be C minus K. Encryption is M plus K, message plus K. K will be 3, let us say. If you do like that, A will be converted to, suppose A equal to 1, B equal to 2, A plus 3 if you are doing, it will be D. Julius Caesar in his drama, how many of you know Shakespeare dramas? How many dramas are available by Shakespeare? 36 dramas are available. Okay. One such drama is Julius Caesar. In that, this sentence is coming, I came, I saw, I can go. In that language, in Latin language, it was vini vidi vici, like that it is written. In English it is, I came, I saw, I conquered. He succeeded, he was giving this message. But secretly he wanted to give. He was encrypting and sending the message. So when he was sending secretly, it was converted like this. I, after JK, it is L plus 3. Similarly, C, after DE, it is F. A, after BC, it is D. So, I came, I saw, I conquered, is encrypted to L, FDPH, L, VDZ, like that it is converted. Now the plain text, everybody can read, but the cybertext is not intelligible, unintelligible. You want to convert to plain text. How will you convert the encrypted message to plain text again? Minus here. For this, the second formula is, you see the formula, it is minus. The first formula, it is plus. The second formula is just minus. Now, different types of attacker are there. The attacker knows the algorithm, but he will not know the key. Always you should think that the attacker knows the algorithm. The attacker knows the ciphertext. He wants to get the plain text. He does not know the key. If he knows the key and the algorithm, what can be done? Immediately decryption can be done. He does not know the key. He is trying to do some attack to know the key. One type of attack is called brute force attack. Brute force attack means trying all the combinations. Suppose you are forgetting your number in the number lock. How will you do the brute force attack? Start with 000, try to open. 001, try to open. Then 002, like that if you are going on, trying all the 999 combinations, you will be getting. That type of attack is called brute force attack. in Julius Caesar time, to do a brute force attack of a message written in a letter, it was taking years together. But now, after the arrival of computer, fraction of a second only it is taking. Therefore, Caesar cryptography is no longer useful after the arrival of computer, but this is giving an idea to change the plain text into ciphertext. He was giving the idea before 2000 years itself, many years before itself, 2000 BC. So 2000 BC means before the arrival of Jesus Christ, 2000 years. So after the arrival of Jesus Christ, 2023 years are 2023 years are over now. But 2000 years before means Julius Caesar time is 4023 years. So that time itself he has found this cryptography. What kit it is? He is doing a frequency analysis in English. Whatever letter, which letter is coming more number of times is E, then T, R. The frequency of occurrence of English letters in a paragraph or in a document, if you search, E is occurring more number of times. After that, T, this is the combination. Then digraph means 2 if you take, TH is appearing more number of times, he, in, like that. Trigraph if you take the, and, these are all the most frequently occurring words. So, if you want to do cryptanalysis in English, for a plain text, it is looking like this, which is having the highest one. If you see the first one, A, B, C, D, E is having the highest, tallest bar. But after after applying Caesar cryptography, E is not having the tallest one, which is having tallest bar. It is H. So it should be G. E means, sorry, H only, FG. E after FG, H. H is having the tallest bar. They understand that E is transferred to H. This is the method of doing analysis. This is called cryptanalysis. Now let me come to another cipher called Hill cipher. I told the Julius Caesar, Caesar cryptography, it was just addition. Addition is easy to decrypt using subtraction. But next cryptography was proposed by Hill. It was also before hundreds of years. He told that you have to use this method, C equal to Kp mod 26, where K is a matrix, P is a matrix, and C is a matrix. You see, multiply your plain text matrix with a key matrix. So you have to multiply the plain text matrix with a key matrix to get a ciphertext matrix. So you see the formula, C equal to K into P mod 26. For decryption, you have to find the inverse matrix for K matrix. So matrix inversion will be difficult than subtraction. Subtraction is easy or matrix inversion is easy? Subtraction is easy. Matrix inversion will be somewhat tough. Therefore, so this is the formula. Suppose we are going to use view as plain text is view. You want to encrypt the text VIEW. View is for plain text. They start ABCD like this: A equal to 0, B equal to 1, Z equal to 25. Okay, they start like this: A equal to 0, B equal to 1, C equal to 2, D equal to 3, Z equal to H equal to 23, Y equal to 24, Z equal to 25. Like that. Starting from 0. Now view, V will be, it will be 20 first letter. Similarly, I 8th letter, E 4. You can verify this easily. E will be A is 0, B 1, C 2, D 3, E 4. So this E is written as 4. Similarly, W is written as 22. Now key we are taking as quickness. So if you write quickness in a 3 by 3 matrix, it is written like this. Now Q will be 16, U will be 20, I is 8, C is 2. This very easily you can verify. C equal to 2, easy to verify. All other letters you have write and check. But you can check C equal to 2, K equal to 10, N equal to 13, E equal to 4 like this. We have taken a key. So we have a plain text matrix, we have a key matrix. Suppose the key is smaller, you have to repeat the key. For example, Ram, let us, key is Ram. You have to repeat Ram for 3 rows. Now, the complications are all matrices are not having a inverse. For example, the corresponding determinant is 0, the matrix will not have a inverse. So they assume that the matrix is having a inverse. Let us take an example. Attack we are going to encrypt. Under the table also they have given for easy reference. A is 0, B is 1, C equal to 2, like that one table is also given. We are going to take the plain text attack. We are going to encrypt. After encryption, they are showing the result as FK, MF, IO. We are going to get this. So how we are going to get? Here, mod 26 is very important. Okay. For example, W is coming. So which letter I will be putting? 22. W equal to 22. When W equal to 22, suppose we are adding 3, it's not a problem. Z let me take. Z 25. If you add 3, what will happen? 28. But 28 alphabets are not there. You have to use mod 26. 28 mod 26 is how much? 2. So it will be coming to 2. That way you have to. 2 means it will be C. Attack, we are splitting like this, AT, TA, CK. Three columns we are taking. The reason is we are going to make it as a 2 by 2 matrix, as the key they are giving us a 2 by 2 matrix. Since key is a 2 by 2 matrix, the word attack is divided into AT, TA, CK. So first we will encrypt the first one, AT. AT, A will be 0, T will be 19. Key is 2336, C equal to KP mod 26. You have to multiply the two matrices, key into plain text. If you multiply, you are getting 2 into 0 plus 3 into 19, 3 into 0, 6 into 19, mod 26, 57, 114, 57 mod 26 will be how much? How much is 57 mod 26? 2 times 26 is how much? 52. So 57 mod 26 will be how much? 5. 5 is which letter? F. F. So 5 is becoming F. Similarly 114 mod 26. 2 times 26 is 52. 4 times 26 is 52 plus 52. 52 plus 52 is 104. So 114 minus 104 is 10. This is the 10th letter. K. So we can see the table. Suppose whenever we have a problem in that, this K is 10. There itself 10. So I have converted the first one into FK. Similarly, the second one is converted to MF. Third one is IO. Overall, the ciphertext is FK, MF, IO. Are you able to understand all the three? Okay. So we have converted the plain text into ciphertext. Now we have to convert the ciphertext into plain text. We have to do inverse. For doing this, P equal to K inverse C mod 26. K inverse equal to 1 by determinant K into adjoint K. This is the formula. You know the matrix inverse formula. What is the inverse of a matrix? 1 by A, let us say matrix is A, 1 by determinant A into adjoint A. So determinant A, how will you find? The corresponding matrix you will be writing in determinant form. Just you have to cross multiply if it is 2 by matrix 2. So the matrix determinant equal to ABCD. You have to expand like AD minus BC where D is not equal to 0. Now in this determinant is 2, 3, 3, 6. You know the key. Already you see this is the key. What is the key? First row is 2, 3. Second row is 3, 6. So the D equal to 2, 3, 3, 6. If you expand the determinant, what you are getting? 3. 12 minus 9 is 3. But it is not just 3. D equal to 3. You have to find 1 by 3. 1 by D. 1 by determinant A. 1 divided by determinant means D inverse. D inverse, how will you find this? In modulo pi algebra, I will tell you. After that, we will go to modulo 26 algebra. If you say A equal to pi, 1 by pi is the inverse in multiplication. Why 1 by pi is the inverse? When you multiply them, you have to get identity. Identity means with the identity, if you multiply anything, you get the same thing. That means the inverse in multiply normal multiplication, the inverse of pi is 1 by pi. The inverse of 7 is 1 by 7. Like that we know. In modular algebra, let us say mod pi, what is the inverse of 2? 2 into something will give 1, 1 mod pi. 2 into 2x mod pi equal to 1 mod pi. So what is x? 3. 2 into 3 is how much? 6. 6 mod pi is how much? 1. Therefore the inverse of 2 is 3. Let me take modulo 7 algebra. Okay. In the modulo 7 algebra, what is the inverse of 2? 2 into something equal to 1, mod 7. If you take 2, 2 2s are 4, it is less than 7. If you take 3, 2 3s are 6, it is less than 7. If you take 4, 2 4s are 8. 8 is only correct. Therefore, the inverse of 2 is 4. This way you have to find the inverse. Here they are finding the inverse. You see the inverse. D equal to 3. D inverse is how much? 9. How it is 9? You see this line. 3 into 3 multiplied by 9 mod 26 equal to 27 mod 26 equal to 1. Therefore, D inverse equal to 9. When D equal to 3, D inverse equal to 9. Anybody could not understand this line? The inverse of 3 in modulo 26 algebra, it is 9. Anybody could not understand? Everybody would have. Everybody is able to understand. If you don't understand, you start with 3 into 1, mod 26. It is less than 26. 3 2s are 6, mod 26. 6 is less than 26. Then 3 3s are 9. 9 is less than 26. 3 4s are 12. 12 is less than 26. 3 5s are, I am trying, 15. That is also less than 26. 3 6 are, I am trying, 18. That is also less than 26. Then 3 7s are 21. That is also less. 3 8s are, that is also less. 3 9s are 27. 27 mod 26 you check. 27 divided by 26 giving the remainder 1. Shall I divide and show or everybody understand? 27 divided by 26, what is the remainder? 1. Mod means remainder. So the remainder is 1. Therefore, the inverse of 3 in modulo 26 algebra, it is 9. So we found 9. To find the adjoint of matrix ABCD, you can, they are giving a simple form. This D and A you have to change the places. For C and B you have to change the sign. Through this also you can find the cofactors of everything and find. If you find and reach, it will be coming like this only. How will you, what will be the cofactors of A in this? It is A11, let us say. It will be positive or negative? A11, A12, A21, A22. Assume that this is A11, this is A12, this is A21, A22. Now A11, 1 plus 1 is even number, therefore you have to put positive number. A12, odd number, you have to put negative. A21, negative. A22, positive. That is why in the result also, here and here positive, here and here negative. Now how this is coming is, for this one, you leave this row, leave this column, whatever is remaining, that you have to take. If it is a 2 by 2 matrix, it is single element. If it is 3 by 3 matrix, there will be a small matrix. You have to take that matrix to find the cofactors. So here, the cofactors of A is just D. Cofactors of B is, it will be negative, but it is okay. First you have to find the cofactors. After that, you will be finding forming a matrix. Then you have to find the transpose. When you do the transpose, it should have been here. That will come here. So you know how to find the inverse. First you have to find the cofactors from the matrix. You have to find the transpose of the cofactor matrix. So when you do the transpose, that place will change. Therefore, C and D, these two will be changing the places. This and this will not change the place. Even if you do transpose also, first row first column will be in first row first column only. Second row second column will be in second row second column only. Even if you put a transpose, you know what is a transpose? What is transpose? Row will become column, column will become row. So the matrix is matrix of cofactors is transpose. That is only written here. Now if you write it like this, K equal to this one, adjoint of K will be this one. This 6 and 2, they will be changing the places, and 3 and 3, it will become negative. And here, you understand from this to this, the last 2, 3, 3, 6 to this one, using this formula only. ABCD is transferred to D minus B minus CA. So from this to this transfer. After that, are you able to understand this? Mod 5 if I take, 6 mod 5 is how much? 1. 11 mod 5? 1. 16 mod 5? So in modulo 5 algebra, 6 equal to 11 equal to 16 equal to 21 equal to 26 equal to 31 equal to 36 equal to etc. Similarly in the negative side also it can come. Okay, I told 1 equal to, but 1 minus 5 equal to 4, minus 4. So minus 4 and 1 are equal in modulo 5 algebra. Similarly minus 4 minus 5, it is minus 9. Minus 9 equal to minus 4 equal to 1 equal to 6 equal to 11 equal to 16 equal to 21 equal to 26 equal to all are equal. So if you are going on adding 5 or going on subtracting 5, they are all equal in modulo 5 algebra. That is why minus 4 equal to plus minus 4 plus 1 is how much? 1. So minus 4 equal to 1. 1 equal to 5. Sorry, 1 equal to 6. 6 equal to 11. 11 equal to 16, like that. So you can go on adding pi. You can go on subtracting pi. Minus 4, minus 9, what will be the next one? Minus 4, minus 9, minus 9, minus 5 is how much? Minus 14, minus 19, then minus 24, minus 29, all are equal. So you can say that minus 29 equal to plus 1, minus 29 equal to plus 6, like that you can say in modulo pi algebra. In this way, you can add 26 here. Here it is modulo 26 algebra. You see, it is modulo 26. If you add modulo 26 to this, what will happen? Minus 3 to add 26. The modulo pi algebra, you are adding pi. In modulo 26 algebra, you have to add 26. So minus 3 plus 26 is how much? 23. So this minus 3 is equivalent to 23. 23 is equivalent to 49 also I can write. Can I write 49? 49 also you can write. 49 also correct. One more 26 if you want to add, it will be 65 also. All are equal. So minus 3 plus 26 is how much? Minus 3 plus 26 is 23. So minus 3 is equivalent to 23. The modulo 26. Modulo 26 algebra means you can add 26. Minus 3 plus 26 is 23. 23 plus 26 is 49. 49 plus 26 is 65. 65 plus 26 is 81. Correct? 65, 85, 86. Okay, like that you can go on adding. 86 or 91. 91. Like that you have to add 26. Always, if you add 26 to the existing one, it is equivalent. In this slide, anybody has any doubt? Are you able to understand? Okay. Now, inverse of the matrix K inverse equal to 1 by K. Adjoint of K, that formula when you apply, K inverse equal to, this is the determinant value, 1 by determinant. It was 9. Determinant was 3. 1 by 3 was, what is the inverse of 3? In modulo 26 algebra, 9. We found that. So 9 into, then the previous slide, the values are copied. 6, 23, the matrix you see, 6, 23, 23, 2. We are having this matrix. Now let us multiply. 9, 6 are, you multiply 9 and 6. 9, 6 are 54. 54 is equal to, in modulo 26 algebra, 2. Understand how 54 equal to 2? How it is 2? 2 times 52 is, 2 times 26 is 52. At 52, if you subtract, the remainder is 2. Therefore, 54 is equal to 2. Like that, 207 is 25, 207 is 25, 18 equal to 18 only. Now, you want to decrypt means, this is the first ciphertext, second ciphertext, third ciphertext. You will be writing in this format. Now, plain text equal to K inverse C mod 26. It is K is 2, 25, 25, 18. This is only K inverse. In the plain text, the first plain text is 5, 10. I am writing this. You multiply them. If you multiply, you are getting this. And 260, 305, it is 0, 19, 80. After decrypting, it is 80, TA, CA. Attack. The plain text is attack. You check whether you are able to understand. If you understand one set of decryption, this one if you understand, similar to that only this and this. You check whether you are able to understand this first line. This line if you are understanding, you can understand all the lines similarly. So the next encryption technique is called called Pfeiffer cipher. Okay, going to talk about Pfeiffer cipher. The best known multiple letter encryption, polyalphabetic substitution, single alphabetic substitution, like that. Different methods are there. The single alphabetic substitution, like Caesar cipher, one letter will be substituted with a different letter. But here we will not be seeing a single letter, multiple letters together. We will be doing the encryption. One example. I want to use monarchy as the key. First I am talking about a key. Then let us come to plain text. Monarchy is the key. We will be arranging the alphabets in 5 by 5 square. 26 alphabets are there. That I and J has less frequency. Therefore I and J will be put in the same square. All the others they will be putting in the different square. But you have to choose a key. First you write the key. After writing the key, remaining letters you have to write. First you have to write the key, then remaining letter other than the key. I am writing monarchy. Monarchy, how much places it is coming? How many letters are there in monarchy? 8 letters are there. So 25 squares are there. That is 5 by 5 square we have taken. 25. In that 8 are already occupied by monarchy. Remaining we are going to fill with the remaining letter of the alphabet. Start with A. A is available in monarchy. The letter A is available in monarchy. Yes. Letter B is available in monarchy. No. So we have to put B now. So after monarchy immediately B is put. C is available in monarchy. Yes. And D is available. No. So after B we are putting D. Like this. Remaining letters are like that. Remaining letters are B, D, E, F, G, I, J in one box, K, L, P, Q, S, T, U, V, W, X. This is the arrangement. First you write the key, then leaving the key, all the other letters into the 5 by 5 matrix. We have formed the key. This is the first step. If you read this, the Pfeiffer algorithm is based on a 5 by 5 matrix of letters constructed using a keyword as shown below. Here monarchy is the keyword. So first we write the keyword. Other than the keyword, all the others we will be writing together. Next page. It was, you see the last sentence, it has only 26 letters. So combinations will be 26 by 26 combinations, diagrams we can make. So analysis is taking 676. The times you have to try, you can find the key. But during World War, all the world countries were fighting. They were not able to take it to this. Okay. All the world countries were. When I was in Baba Atomic Research Center, I was in Navy group. And when I told I am coming from Tamil Nadu, some people were very happy since we were participating in India-Pakistan war. And they told one group of commandants were South Indians, Tamil, Malayalam or something. So, when Pakistan and India commonalities both are talking Hindi only. Okay. So, whatever secret word you say with it to your command, they will understand. But any other Indian language also they can understand it very easily. Only Tamil they cannot understand. Therefore, what they did is, all the commands they will say loudly in Tamil. The Pakistan people, they were not expecting that, and they are shouting in a different language. People are able to hear and they are doing something. What they will do is, within every group, one Tamilian or South Indian will be there. He will translate into Hindi. That Hindi talking will be within a small group. But loudly, when you are transferring from one group to another group, they were doing in Tamil. So, they wanted to do the war for around 8 to 10 hours, but 8 minutes India was winning. The reason was the encryption decryption method they used. Okay. Last sentence if you read, it was used in World War I, and it was also used in World War II. At least they were winning a war also, but they used this cryptography. Now it is looking simple cryptography. Now we will say how to do the represent the plain text. Plain text will be divided into two pairs. Same letter is coming means we will be introducing some dummy thing. For example, allow. Allow, if you divide into two things, HE one word, but LL it is coming, two same letter two times it should not come. Repeated words is not allowed. Therefore, they will put a dummy word called X. So LX, LO. Here, X is a bogus letter. You see, X is a bogus letter. We are writing HE, LX, LO. This is the method of representing hello. Next, LEO, like that it is coming. HE, LX, LO. After that, E is coming without any pair. If some letter is coming without any pair, then also you have to introduce a dummy word, dummy letter. So here they are introducing a dummy letter called Z. So HE, LX, LO, LZ. Now the encryption, how we will do. First you have to form the key, monarchy, followed by all the letters. Rule number 1. Suppose the two letters which you are taking, allow means HE, then LX, LO, like that, two letters we are taking. If the two letters which you are taking are coming in the same row, you have to take the next letters. Same column means down letters. Same row means right side you have to see. Same column means you have to see below. We will see. I will give examples. ME, they are coming in the same column. So what is coming below M, C? What is coming below E, L? So M is encrypted as C, and E is encrypted as L. ME will be, ME is the plain text means encrypt, ciphertext is CL. CL is shown in red color, ME is shaded with green color. Are you getting this? Next, same row. Same row means you have to see right side. Suppose last one means you have to come to the beginning, rotate, cyclic order you have to see right color. Now ST we are going to see. First, what is the next letter to S? T. What is the next letter to T? L. So you have to write S will be to S to T, T to L. ST will be converted to TL. Next, if they are not in same row, same column, then you have to see horizontally and vertically, and encryption, do encryption like this. For example, NT it is coming. For N come down, for D, T come to the left. So same column, you come column and here row, or here row, here column. First let us see the row from the first one. N to right side if you go up to last, T to top if you come on the right side, from the row only we are starting. So N to this side and T to up, they are intersecting in this place. So it will be converted to R. N is converted to R. Next, N here come down, here come to the left, it is Q. So RQ. So same row, same column. Okay. 2 times they will be intersecting. How many times? N and T are intersecting how many times? In first you see N, if you go right, T go up, they are intersecting in this place. Similarly, M to come down, T you come to the left, this N and T, they are meeting at Q. So in this way you have to see. you have to start from first letters column, sorry, first letter row. Then second time first letters column. So nt is converted to RQ. So we can take a key, any key we can take. Little bit letter also no problem. Suppose you are taking a key A 2 times, then the encryption may be doing some confusion. But when you take a larger test, then by analyzing that they can find. Normally, key if you take uniquely, it will be easy to encrypt. They did not say any rule on that. So my guess is only we can allow. How that I and J they are allowing, but that will be I or J by analyzing many times, many words they find whether it is English, which will be more suitable in English. After that, once again you have to do English language analysis. Then we can. So these are all instruments with monarchy. Whatever rules I have told so far, all the rules together, it is for a bigger word, instruments, but I to G, N to A, S to T. First IN you have to take. IN will be converted to GA. Next ST. ST will be converted to PL. Next you have to take INST RU. So RU will be converted to MU. Where is RU coming? RU. RU will be coming to MZ. Like this. So a bigger example is taken. Why 2 into 6 equal to 1? 2 into 6 is 12. 12 mod 11 is 1. So 2 into 6 equal to 1. Therefore, the inverse of 2 is 6. The inverse of 6 is 2. So this point, if you are able to understand, then whatever cryptography I am doing, it will be convenient to you. Otherwise, it will be. I come to some other algebra. Can you find 5 mod 11? You have to write pi table. I ones are 5, I twos are 10, I threes are 15, I fours are 20, I fives are 25, I six are 30, I sevens are 35. then you find out what is x. Find something mod 11. So 5 ones are 5, 5 twos are 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 95, 100, 120, 120, 125, 130, 135, 140, 150, So I found it. Do you understand how did I find? Which one? 9 itself is coming. 5 9s are 45. Correct. Okay. 5 9s are 45. So 45 divided by 11, 4 times 44, carry 1. So 9 is the correct inverse. Then 9 is the first prime inverse. 9 plus 11, 20 also will come. 20 plus 11, 31 also will come. 31 plus 11, 42 also will come. So I found the second one. So who found the first one? You? Yeah, that is the correct answer. So you have to find the inverse like this only. You can find many number of inverses, but what is the first inverse, the prime inverse we say, that we have to find. So what I did is 5 table I am doing. 5 ones are 5, 5 twos are 2, sorry 10, 5 threes are 15. 15 mod 11 is 4. Then I am coming to 5 fours are 20. 20 mod 11 is 9. So it is not equal to 1. 1 should be shifted. After taking mod, only you have to take. So 5 5s are 25. 25 mod 11, 3. It's not 1. You have to take 1. And like that, if you come, 5 9s are 45. 5 9s are 45. 45 mod 11, 1. So 1 we get. So once we get 1, 5, the inverse of 5 is 9. This is the difficulty issue of that, I think. Okay. Actually, I was not told that whether it is the participants are students or teachers. I was of the idea that summer school means it was conducted normally for teachers. So I prepared for teachers, but I am teaching for you. That's why it may be looking fast to you. For me, it was looking slow. Okay. If you feel that I am fast, you tell me. I reduce my speed. This very good one. Actually, this environment, the board also due to me. I learned now, okay. The usage of that board. I was practicing with that type of board. Next cipher is binary cipher. In this, you will be writing the plain text followed by keyword. First, we will create a table. Before creating the table, keyword is the key. Let me assume that I use is the key. What is the length of the plain text? Jigs per jigs. How much is the length? 12, no? What is the length of the plain text? 13. So I use is only 5. So even if you write 5 times, 2 times I use, it is only 10. So I use, then once again AYU. You see where it is written. This place. 2 times I use, 1 times AYU. The reason is jigs per jigs, it is a plain text, just 13 letters. The key I use just only 5 letters. You want to make it as 13 letters means you have to repeat I use. How many letters you want, that much times you have to repeat. So 2 times if I am repeating I use 10 letters. Then 3 more letters you want. If you put I use once more, it will become 15 letters. But I want to have only 13 letters. So AYU. That much. You understand how the key is made? Okay, you have to guess the key. Or your key, you match the plain text. If it is more, you repeat the key. So here in our example, the plain text is jigs per jigs. This is the plain text. This is the plain text. This is the key. We have to make a table like this. You see this table. First line ABCD starts from A. First line if you see, ABCD starts from A. Second line ABCD starts from B. Third line ABCD starts from C. But the ending after Z, once more AB. Here XYZ, next line, we start from B, we are putting A in the last. Third line, we start from C, C, D, E, like that, we go up to Z, we are putting AB. You understand how the binary table is made. So you have to create the table first. This table was created by binary. That is why this name is, the cipher name is itself is given as binary cipher. Now we want to make the plain text into cipher text. The plain text is, it is jigs per jigs. I take only jigs. Just for understanding, let me take now I have written 5 letters from the plain text, 5 letters from the key. You see G and A combination. Gth row, 8th column if you see, what will be the result? G only. Next, E, Y combination. E row you come, Like that you come up to y, what is coming? You start from E row E and column y. What is coming? C. Next E row, column U. So E row, column U, y. K and S. K row, column S, C. Next S row, H column. It is Z. So the first five letters G, C, Y, C, Z. You see the encrypted message for the first five columns. G, C, Y, C, Z. Remaining will be similar. If you understand the first five letters, you can proceed like this. Are you able to understand the first five letters? The decryption, whatever you have done from row to column, you have to do in the column to row. So row to column will be converted to column to row. For example, one example, second one, E and Y we are seeing. For decryption, Y and E you have to see. Yth row, Eth column if you see, it will be C. Okay. Actually, Eth column, Yth row, Eth column, correct. Eth column. Yth row, Eth column. It will be C. Yth row, Eth column. Yth row, Eth column. C. Yth row, Yth column. So C. No. You should not take the plain text. You have to take hypertext and key. So hypertext key column we will write. Hypertext was G C Y C Z. G C Y C Z. G C. Now, first you have to take G throw eighth column. G throw eighth column if you take, what you will be getting? G. Y throw sixth column. Y throw sixth column, it will be A. C throw with column. C throw with column. Which one? Here column to row. Encryption from row to column, decryption column to row. So Y and C combination we will check. Y and C combination. Y column. C row. Column 0 will be column 0. You see the last line, row Y, and locate the ciphertext C, which is found in the column E. So the C E is the second. For decrypting, we go to row Y, locate the ciphertext C. So we have to see row Y, we have to search for C. Row Y, search for C, it is available in E. So E is this is the method of it. You understand? With row you come, you have to locate for C, it is available in C. See this one. The with row C is available in each column. You have to take with row where C is available, you have to search. It is available in the each column. Similarly, youth row, you take youth row, you have to search for Y, where it is available. Youth row, search for Y. Y is available in which column? E. So next letter also E. That way. Anybody else? Anybody did not understand? You see the row from the plain hypertext row and hypertext row, keys row, hypertext where it is found. The key row, where is the hypertext found? For example, U means you have to search for which one? If you take U, you have to search for Y. If you take S, you have to search for C. If you take H, let me take H. Search for Z. Where is Z? Yes. So Jigs. So yes. You are able to understand? So I did some algorithm. Now I will be going to the mathematical background of cryptography, number theory. We know all the number systems. First the natural number. So natural number means 1, 2, 3, 4, 5, 6, etc. up to what is the last number? Up to infinity. Set of natural numbers, it is called non-negative number. It is represented by n, 1, 2, 3, 4, etc. Whole number means, in addition to natural numbers, if you include the number 0 also, that is called a set of whole numbers. So whole number starts from 0. Natural number starts from 1. Integer means it includes positive numbers, negative numbers, 0, but without a decimal point, without a fraction, anything. All set of whole numbers, positive and negative. So in the set of integers can be obtained by adding negative numbers also to the whole number. So it starts with minus infinity, goes up to plus infinity, minus infinity, then minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that up to infinity. Rational numbers, it is of the form P by Q, P divided by Q. So the numerator P will be there, the denominator Q will be there. Example 1 by 3, 2 by 3, 4 by 9, 4 by 9, like that anything of the form P by Q, it is a rational number. Irrational numbers will be in the form of root. Examples of irrational numbers are root 2, root 3, root 5, root 7, root 11, etc. These are all irrational numbers. Then real numbers, You know, floating point, real and integer. In computers, we are using always integers and real number. Real numbers will have a full stop, decimal point. One example is 4.5, 7.25. These are all real numbers. Integer means decimal point will not be there. Real numbers will be having decimal point. So the real numbers, any number that we can think of, except complex number is a real number. Complex numbers will have one real part, one imaginary part. A plus IB, we are having that form. Whole numbers, all non-negative integers. So starts from 0, goes up to infinity. Natural numbers starts from 1, it is called a counting number. We start counting from 1 always. That is why it is called a counting number also. It is natural number. We will see what is meant by a factor in the set of numbers. Factor means one can be, a number can be factored into a product of two numbers. For example, 6. 6 can be written as 2 into 3. So the 2 and 3 are called factors. By that, if I am writing the factors of 24 are 1, 2, 3, 4, 5, 4, 6, 8, these are all. Are you able to understand all the factors written on the table? Now, factorization means a number can be expressed as a product of some other number. For example, 6 can be expressed as 2 into 3, 20 can be expressed as 4 into 5 or 2 into 2 into 5, and 7 can be represented as 1 into 7. These are all called factorization. Two and 3 are the divisors of 6. Therefore, 6 can be written as 2 into 3. 2 and 5 are the factors of 20. 2 and 5 are factors or divisors of 20. Therefore, 20 can be written as 4 into 5 or 2 into 2 into 5. You are able to understand what is a factor.